In this video, we're going to be simplifying radicals using rational exponents. So what does that mean? Well, we're going to be taking things that are radicals and we're going to convert them into rational exponents, fractional exponents. So when do we need to do that? So here's what we have. So the directions may say simplify, and you're going to try and simplify the square root of 3 times the cube root of 3. So the problem with that one is you can't combine square roots with cube roots. But the fact that those both have a base of 3 is exactly what we're looking for. So we're going to rewrite the radical as a rational exponent. So the first one is going to be 3, and a square root is exactly the same thing as a 1/2 power. And then it's going to be multiplied by another 3 to the cube root is a 1/3 power. So properties of exponents, we have the same bases. We're going to try to add those exponents together. Now the problem is that we're dealing with fractional exponents. So that 2 and that 3, we need to find a common denominator between them. And they both can become 6. So we can multiply this by 3, multiply that by 3, multiply by 2, multiply by 2, and that's going to give us a 3 to the 3/6 power times a 3 to the 2/6 power. Now we can combine our exponents together. We can add them together. We have the same base. So it's 3 to the 3/6 plus 2/6 equals 5/6. But since our original problem started as a radical, we're going to rewrite our answer as a radical. So the root is the 6th root of 3 to the 5th. Our numerator will become our exponent on the inside. And that is how we combine square roots with cube roots as long as the bases match. All right, because the fact that the bases match allowed us to add our exponents together. So let's see another one. So if we have the 4th root of 27 times the cube root of 9 times the square root of 3. Now this one looks like, because we have a 4th root, a cube root, and a square root, that we can't put anything together. But because 27 is made up of a bunch of 3's, so is 9. We can rewrite those. So we're going to rewrite 27 as 3 cubed. And then that's still to the 4th root. We're going to rewrite 9 as 3 squared, which is still to the 3rd root. And we don't need to rewrite this at all. So we'll just kind of leave it. So this is a bunch of 3's. We just have to do exactly the same type of math we just did here. We're going to rewrite this as a fractional exponent. So that's going to be 3 to the 3/4 times 3 to the 2/3 times 3 to the 1/2. So now we need to get common denominators. All the bases match, so we're just looking to add our exponents, but we can't add the exponents until we get the common denominators because of the fractions. 3 and 4 can both become 12. 2 can also become 12. We got ourselves our common denominator. So we'll multiply that by 3 top and bottom. We'll multiply this by 4 top and bottom. We'll multiply this by 6 top and bottom. And let's see what we get. So that's going to be 3 to the 9/12 times 3 to the 8/12 times 3 to the 6/12. So now we can actually put them together. So we have 3. We can add all of our fractions together. 9 plus 8 is 17, plus 6 is 23/12. And since our original problem did start off as a radical, let's put it back into a radical. It's not a very pretty radical. It is the 12th root of 3 to the 23. And then we could simplify it a little bit, because you're looking for 12 of the exact same thing. Well, if you have 23 3's multiplied together, you can definitely take 12 away from it. So we can take one group of a perfect 12th root, and then we will have, we'll take 12 away from the 23 that we have, which will leave us with 3 to the 11th. All right, one last. So if we have cube root of a to the third b to the second times a square root of a to the second times b. Same issue, cube roots times square roots, but they have the same bases. We just have more of them, but they do match. So we're going to be able to combine these somehow. So we'll start off with, let's rewrite everything. So in this one, we're going to do a little bit of a different approach right away, because we can take this a cubed b squared, and we could just write it as a 1/3 power. All right, if you have multiple pieces in here, it might just be a little easier. So it's basically kind of jumping. There's going to be a little bit of an in-between step in here, but we can rewrite the cube root as all of this to the 1/3 power times a squared times b raised to the 1/2 power, because that's a square root. Now, properties of exponents, you have powers raised to powers, so you're going to multiply this into both. We'll multiply this into both. So 1/3 of 3 is actually going to get us a to the first, and then 2 times 1/3 is going to be 2/3, and then times half of 2 is 1 again, and then b, and this has a power of 1 currently, so 1 times 1/2 is b to the 1/2. So we have like terms that can go together. The a's can go together, the b's can go together. So a times a is going to be a squared. Now the b's, we got to do a little bit of side work for it. So for the b's, we have a b to the 2/3 and a b to the 1/2. We need common denominators out of that. So for our common denominators, between a 2 and a 3, we can both make them 6. So we'll multiply that by 2, multiply that by 3. So that's going to get us a b to the 4/6 times b to the 3/6. And now we can combine them. Since we have a common denominator, we can add our numerators together. So that's going to be 7/6. But now we got to have to go back and kind of mess with the fact that let's put it back into a radical. This is the piece that we're going to have to put back into a radical. So that's going to become a squared's already on the outside. This we'll rewrite as a 6th root of b to the 7th, and we have 6 b's that we can take out. So a squared, we can take out one group of b's, one group of 6, but that will leave us with 1 b left on the inside. All right, and that is simplifying radicals when you're using rational exponents.